Okay, we're continuing on with quadratic equations, and where we're going to go here is looking at how to find the roots of a quadratic function from a graph or from factored form. I'm going to unpack all those words like roots. What do we mean by that? And you may be remembering that quadratic means the highest form of the equation is, the highest power on the equation is going to be x squared, so that's a quadratic right there. And of course you're familiar with what a graph is, and factored form, we did that already, where if I write it this way, that's considered factored. So we're going to be looking at all these things. To do this, I want to start out by looking at a graph. Okay, so let's step over here, and I'm going to type in y equals, I don't know, 2x minus 3, a real simple graph there. And you get a graph that I'm sure you're familiar with. And what I want to remind you is this. Every point along here, if I pick some point along here, every point makes this equation true. So it makes this equation right here true. So regardless of which point I pick, if I pick, let's just go to, see if I can get right on a point there, 3, 3. Okay, what that means is if I put 3 in for x, in fact, if I do that right here, if I put 3 in for x and calculate it, I get 3. Okay. If I go to 4, 5, if I put in 4, I get 5. Okay, so this graph is just a picture of all the answers. Well, I want to ask you a question about this equation right here. What would it take, what would you have to put in for x in order to make it 0? Okay, so what would I put in right here to get 0? So I could try, I could say, well, maybe it's 3. Well, no, it's not 3, we already tried that one. Maybe it's 2. Okay, not quite, we got 1. Maybe it's 1. Not quite, we got negative 1. So it's between 1 and 2. Let's try 1.5. Yeah. Try again on 1.5. Yeah, we got 0. Okay. So another way to look at that would be this. If I'm looking at the equation y equals, let me get a bigger pen here so we can see better. Y equals 2x minus 3, and I want to see what does it take to make that 0. I'll just say, well, let's set it equal to 0, and then find some pre-algebra student and ask him to solve for x for us. Okay. So if we do that, we're going to add 3 to each side. We get 3 is 2x. Divide by 2, you get x equals 3 over 2, or 1.5. So really all we needed to do is just say, look, what does it take to make this 0? So if I have a different equation here, let's make it 1/2 x plus 4. Now let's go plus 1, just so it brings it down a little bit. And so here's the question. Where does it cross, or what do you have to put in for x to make it 0? Well, one way is to look over here and say, well, apparently it's negative 2, because you can just look at the graph. But if you're solving the equation, you could say we got y equals 1/2 x plus 1. Put 0 in for y, and then solve for x. Okay, so subtract 1 from each side. Okay, what do you do to get the 1/2 by itself? I'm sorry, to get the x by itself. Let's multiply by 2. That'll get rid of the 1/2. We get x equals negative 2. So that's what we figured out there. Well, here's where we're going. We're going to be asking questions like that. Where does it cross the x-axis? Either looking at it from a graph standpoint or from an equation standpoint. We're going to be doing that with quadratic equations. So let's get rid of this and put in this equation. Y equals x minus 2, x plus 3. Okay. And so now I'm going to ask you again, where does it cross the x-axis? Well, one option is to look over here at the on the graph and say, well, apparently it's negative 3 and 2. Okay, so we got that from looking at the graph, and so that it's as easy as that. Well, another way to look at this is this. If you look at the equation, y equals x minus 2, x plus 3, our job was to ask, what do you have to put in for x into this equation in order to make this 0? So what would I put in there and there to get 0? Well, option 1, guess and check. That always works. Option 2, look at the graph. That's telling us. Okay, here's another option. I want you to think about this part of this equation right here. Now I'm going to make it pick something bigger. Okay, I want you to think about the gold part and the red part separately. Okay, but here's the deal. Multiplying the gold part and the red part together gets you 0. Okay, so let me say it again. Multiplying the gold part times the red part has to get you 0. So oftentimes in class I'll ask people, hey, would you please tell me 2 numbers that multiply together to get 0? I'll just go around the room and somebody will say 0 and 5. And I say, yep, that works. And somebody else will say -7 and 0. And somebody getting creative says 151 and 0. And that's true. And of course there's always that one person that's going to go -1 billion and 0. And that's true as well. And then I point out, hey, every time you answered this question, you said one of them had to be 0. How come? Well, the only way you can multiply 2 numbers together and get 0 is if one of them is 0. So if I go back over here, what you're telling me is, hey, either this yellow part has to equal 0 or this red part has to equal 0. It's the only way it can work. So here's my question. If the yellow part is 0, what does x have to be? So let me back up here. What does that have to be so that I get 0? Well, it's going to have to be a 2, because 2 minus 2 is 0. Okay, so and we just proved that over here already, that if you put in 2, you get 0 out of the function. Well, what's the other way to get 0? Well, if this thing here, this whole red part, is 0, what does x have to be? Well, it's going to have to be -3. So that's what you figured out over here when you looked at the graph, was it crossed at -3. So what you found out was that looking at the equation, okay, either x was 2 or x was -3 in order to get 0. So you're going to be looking at equations in 2 different ways. One is if I type it out, let's write a new one here, x plus 3, I'm making a mess here, x minus 5, okay. So where does this equation cross the x-axis? In other words, what does it take to make it 0? Well, you can look on the graph and you can tell right here. -3 is one of them, and 5 is one of them. Okay? But you can also look up here at the equation and point out, look, if I've got x plus 3 there and x minus 5 there, first question, what does it take to make this part 0? Well, that's going to have to be a -3. Next question, what does it take to make this part 0? It's going to have to be a 5. So you were able to answer the question either by looking at the graph or by looking at the equation. Now notice that the equation's in factored form, and that's important. We'll get to that later. So we're asking the question, mathematically the question is, what are the roots of this equation? In other words, what do you have to put in here to get 0 out of this function? We call them roots. So I'm going to forget the graph for just a little bit and say, what are the roots of this equation? Okay. Well, Well, you could graph it and tell, or you could say, look, it's going to have to be -2 because that's what makes this 0, and it's going to have to be 7 because that's what makes that 0. So the roots are -2 and 7. If you were to graph it, you'd see that it across there. Okay? Well, there's one last thing I want you to look at. What if the equation looks like this? Okay? A little bit more complicated. Well, the question is the same. What does it take to make that 0? And what does it take to make that 0? So let's go back to the first one. Let's just say it is 0 and solve for x. Okay? We'll add 5 to each side. Divide by 2, you get x equals 5/2, or 2.5. Okay? On this one, what does it take to make this 0? Well, set it equal to 0 and find out. Okay? We'd add 6 to each side. Divide by 3. X equals 2. So now you found the roots by just setting each of the two parts equal to 0, solving for x, and you're done. And if you were to graph this, you'd find out that it crosses at 2 and 2.5. All right? That's going to do it.